Hey, what's up? Welcome back. In this episode, you'll learn how to solve day 13 of the Advent of Code for 2023. This one's called Point of Incidence. And we've now landed on Lava Island. We don't see any lava. Instead, what we see is a bunch of rocks and ash, and there are mirrors in Lava Island somewhere. We're making notes of patterns that are happening on the ground. And this is our puzzle input, is our notes. And it's going to be in these chunks of patterns. So this first one is a chunk, and then the second one is a chunk, and they're separated by two new lines. And in the pattern somewhere, there is a line of symmetry. So we need to find the line of symmetry that is where kind of the mirror is. If you close your eyes a little bit, you'll start to notice the forms that take shape from the different pound sign and dot patterns. So in this first pattern, you'll notice that the first 5 columns here are a mirror of the last 4. And the first column doesn't have a matching column on the other side, and that's okay. So we just care about patterns being symmetrical about some point or some like row or column. And then in the second pattern, we have one where it is horizontal, like this, the symmetry is horizontal around this point 4 and 5. The solution for part 1 is to summarize our pattern notes. So if we have a vertical mirror, then we want to count the number of columns that is on the left side of the mirror. If we have a horizontal mirror, then we're going to count the number of rows that is above the line of symmetry. So let's grab our example input here and get started. We'll open up main.rb and we'll start with input here being equal to something like this. All right, the first part is we want to parse out our input. So we can say, I don't know, the patterns are input dot, we'll split on 2 new lines, and then we'll map each of those chunks of patterns, and we'll split that on new line. And then we want to map that to characters. And I think this should give us back something reasonable. Let's take a look. Okay, so this looks like what we want. So we have an array of patterns where each pattern is an array of arrays. Each row in the pattern is all of the different characters that are in that thing. So the way that I thought about this was to first kind of like break down the problem into individual lines. So like, what is the point of symmetry, or what are the points of symmetry for this first top line? So if you look at it and you go, okay, the first column can't really be symmetrical with itself. So we really need to start with the pair of the first 2 columns. And those are not, there's no symmetry there. And then if we keep going, technically we don't have a line of symmetry around one point. So there's always going to be a pair of elements that are the same next to each other. So that one doesn't work. Here, these 4 are not symmetrical, these 5 are not symmetrical. But if you look at all the way over to the right here, we have dot, pound, pound, dot, and that is symmetrical with dot, pound, pound, dot. So we are looking for, ideally, the number here, which is the number of 1, 2, 3, 4, 5. We want to get back 5, and that's the number of columns that are to the left of the point of symmetry for this specific row. So we can grab onto that. Let's actually also require rspec auto run. We'll describe some method like around or something. Yeah, we'll just call the method around. It returns true if a pattern is symmetrical around a given point or something. I don't know. So we want to expect that this around method of some pattern, and we'll give it characters. And if we say, is it symmetrical around the number 1? Then we expect that to be false, right? We don't think it's symmetrical around 1, 2, 3, 4, 6, 7, or 8. We do think it's symmetrical around 5. So we want to basically just say, we'll be pretty explicit here. Okay, and then around 5, we think it is true. Okay, so then now we'll go run our thing here. Around is not available. That's because we haven't defined it yet. So we'll make a new method here, around, and this is going to take in some line and an index. All right. Expected false got nil. We need to partition the line around that index. So we're going to pass in 1, 2, 3, 4, 5, 6, 7, and that's going to let us like split up the line into 2 different sections. And the way that we can do that is say we're going to have a left and a right. And there is a method on array called partition. So if we look at that for a second, so if we have A is 1, 2, 3, 4, 5, 6. A.partition takes in a block, and if it evaluates to true, those end up in one bucket. If it evaluates to false, the other ones end up in the other bucket. In our case, we want to use this method with the index of the element. So again, we can use with index on the end here and pass that in. So now we have some index, and we want to say if the index is greater than 3 or something, then partition. Or I guess technically we want it to be less than, so that we have our left on the left and we have the right on the right. So this, by passing in 3 here, that splits it at the third point where we'll have 3 columns on the left. So again, if we partition on 4, then we end up with 4 columns on the left. So yeah, let's do partition with index, and we'll have our character and we'll have our local index, where the index is less than index, and now we end up with left and right. You'll notice again, though, if we are partitioning at a point that's not smack in the middle of the index, then we end up with one part of the array that's longer than the other part. We want to take the minimum of the 2 and just check. We want to check only that length. That kind of gives us our midpoint. We want to get some length, which is going to be the minimum of left and right. Now what we want to do is we want to go left is equal to left dot reverse. Okay, so as we're comparing these, we want to flip it around, and then we'll check from that point up to the other. So in this specific case, if this was our left, we would have dot pound pound dot, and then this pound sign would be at the end. And what we're going to do is trim off any leftover chunks that don't match up to and including that point by using this array subindexing. For instance, here, if we had left and right, and we said left from 0 to 2, 0 not including 2, then we get the sub array that is just 1, 2. Technically we want 3, 4, so we'll say dot reverse, and that would be what we're looking for, 4, 3. Okay, if the left is equal to the right, I'm not sure if that's what we want, but let's start there and just see if our tests pass. Okay, expected false but got true for number 7. 7. 1, 2, 3, 4, 5, 6, 7. Yeah, I guess technically 7 is also correct. So this should be true, because this is like a point of symmetry if we chop off the rest of this stuff, which we do want to do. And then 8 should be false. Okay. Oops. All right, so we've got a passing test, and we have a method that will tell us whether or not something is symmetrical around a given point. Now what we want to do is go through and find all the points where a line is symmetrical. I call this one maybe points of symmetry, and this will take in a line, and this is going to return an array of points. So now we want to do something like 1 up to line dot length, select, that might actually work. So now let's do another little test here. So it finds points of symmetry. Expect that points of symmetry for that is going to be equal to 5 and 7. Let's see. Okay, that's passing. So yeah, so when we pass this in, we should get back 5 and 7. The idea is that we'll go through each row and find the points of symmetry, and then we'll have to find all of the points of symmetry for all the rows, and then we will find the intersection of all of those. And if it's symmetrical, that should give us the point that is symmetrical. So we've got the points of symmetry. Now what we want to do is find the lines of symmetry. So lines of symmetry, and this is going to take in a full pattern. And lines of symmetry is going to go over each of the rows or each of the lines of the pattern. So pattern.each do line, and, or yeah, I guess we can map this onto points of symmetry. So let's see if we can get something out of that. Finds lines of symmetry. Okay, so then we'll just use this as our part of our test here. Okay, and pattern is input.split.map. Let's see if that gives us what we expect. Okay, that looks good. So now what we want to do is pass this pattern in. So we expect that lines of symmetry for the pattern is equal to the element 5. I think that should maybe work. Okay, pattern. Pattern. We spelled this wrong. Okay. I'm just going to close that because I keep navigating over there. All right, so we expected 5, but we got 5, 7, 1, 5, 1, 5, 1, 5, 1, 5, 1, 1, 3, 5, 7, and 5. So you'll notice there is something in here, and that is that the pattern is the same. One really cool thing you can do is if you have an array of arrays where we have maybe 1, 2, and 2, and 2, 3, and we want to find the intersection of all of these arrays, we could say B is the first A and C is the second A. And then we can do B ampersand C. That will give us the intersection. So that tells us like what's the same in both of them. So this operator here is something that we want to apply to all of the elements. So we can say a.inject and pass in like A, or I don't know, D and E as our arguments. And then we can say D ampersand E, and this needs to be an array. And then we're going to get some like accumulator. No, we don't want to pass an array. Okay, so if we pass an initial argument, it uses that as the first D or the first like element. But if you don't pass any arguments, then it uses the first element of the collection as the first argument. In this case, we want to apply this intersection operator against all of these elements. So we can do this, but inject, recall that inject has this shortcut where we can say ampersand, colon, and then the name of a method. And in this case, the method name is also called ampersand. This is the first time I've seen this, and I think it looks pretty cool. It's 2 ampersands holding hands or something, holding a colon. All right, so we're going to say ampersand, ampersand, and that should do something for us. Oh, look at that. Boom, we got a passing test. Okay. All right, so now we have lines of symmetry. Now we can use lines of symmetry for the pattern for both rows and columns, because now what we can do is just pass in the transposed grid to get out any columns. So what we want to do now is go over each of the patterns. So we'll comment this out and say patterns.each do pattern. And for each one, we want to get the lines of symmetry, rows. Maybe we'll just call it like sim rows, and that'll be that, and sim calls will be that. And we can print out sim rows. Actually, I think this is backwards. I think this one is going to do the columns, and this one is going to do rows. Okay, so now we'll just say rows is rows and columns is columns, and we'll run it. And okay, one of the patterns is symmetrical around the 5th column, and the other pattern is symmetrical over the 4th row. which does match up with what we're expecting. So we can say that our answer here starts at 0. And what we want to do is say answer plus equals, I think there's a special pattern here. So 100 multiplied by the number of rows. We'll do sim rows.2i times 100 plus sim columns 2i. And that should give us a number. Because we only have one. We'll just grab off the first result there of our lines. And it says no examples found, but really what we want to see is puts part 1 answer is answer. And what do we got? 405. Okay, that is what the example is expecting. Let's grab our input. Our puzzle input looks like this. We'll drop it here at the end. And then instead of input being input, we'll override input to be data.read. We'll rerun this, and we get 34889. 34889 is, boom, that is the answer for part 1. Okay, we're able to check where the mirrors are and find the answer based on the symmetry that we're finding on these rows and columns. Okay, part 2. We keep walking through, we're walking through Lava Island, and boom, we run into a mirror. That's because some of the mirrors have smudges on them. I hate smudges. Smudges, smudgy, smudgy, smudge. And so it's possible that a single dot in the pattern is incorrect. And so we need to figure out now if the mirror was in a different place because one of these notes was incorrect, we need to swap exactly one period to a pound sign or one pound sign to a period and see if it's valid. Now, there's a bunch of different ways that you can do this and a lot of optimizations. I did not take any optimized approach. I just said, okay, let's take the entire grid and one by one, we will replace each of these things with the opposite and we'll check to see what lines of symmetry we end up with. Okay. So what we want to do is while we're iterating here, we're going to go through all possible rows and columns of the pattern. So we want to say pattern.each with index do row, and sure, the row index, and then row.each do index column index. Okay, we have to go through every single cell, right? So we need this doubly nested loop here. And what we want to do is like at row index column index, swap from dot to period or period to pound sign, right? So let's do this. Because we're going to be modifying or like working with another array inside of here, rather than updating pattern itself, we want a sub pattern, which is pattern.mapDup. We want like a duplicate of that. And we want the sub pattern at row index, column index to be swapped. So this should give us the swapped element at that single index. Then what we want to do is get the sub rows, and that's going to be lines of symmetry, and then sub columns, which is going to be those lines of symmetry. This time, instead of grabbing off the first one, what I found was as we're going through and changing these different smudges, we might end up getting back the same line of symmetry that we already had when we had like a pristine smudge-free mirror. And so what we want to do is grab all the possible lines of symmetry for both of these, and we want to collect them up and then remove the valid lines that are here. We actually want to keep track per pattern. Sub rows is going to be actually let's use a set because this is going to be unique for the pattern. So we'll have sub rows and sub columns, and then here we can do plus equals. And then we should get some sub rows and sub columns per pattern. And eventually we're going to want to remove the sim row and sim column. So let's take a look at what this looks like against the example input. So let's just run it. Okay, so sub rows is 3, sub columns is 5. It'll also help here to print out the rows and columns for the pattern. And at the beginning of a pattern, let's also just like print out something so we can know the separation between patterns. Okay, so for this first pattern, there are no rows that we're symmetrical around, and we're symmetrical around column 5. This is when we're smudge free. Now, when we start to introduce smudges, we can see symmetry around the 3rd row. And you'll notice that we still see symmetry around the 5th column, and that's because it's picking this up when we smudge something that's not even in scene before we check that. Similar down here, we have rows when it's unsmudged, and we have this other one. So we basically want to remove our existing valid ones from the sub rows. So here what we can do is say sub rows minus equals sim rows, and sub columns minus equals sim columns. And now we should see something different. So now we just see the set with 3 and the set with 1, and that is correct. So our answer for part 2, I'm going to move this up here. That's all our part 1 stuff, and then our part 2 stuff is down here. So let's say answer 2 is equal to 0, and we want answer 2 to be equal to the same sort of deal as here. So let's actually just copy this and paste it here. And then instead of sim rows, this is going to be sub rows dot first dot 2i and sub columns dot first dot 2i, and we're expecting 400, and we got 805. Because we're incrementing answer, this should be answer 2, and then we want to print out the part 2 answer 2. Boom. Okay, so for part 1, our answer is 405. For part 2, our answer is 400. And that's looking pretty good. Okay, if we run it against our actual input, that's super messy and loud, but whatever. We'll just let it run. Okay. I think there are 100 patterns in the example input. We get this huge output. All right, 34224 in the, so that is our answer for part 2. Awesome. Okay, definitely another really tricky one. And I think there's technically another approach too, where instead of checking to see if the left and right are equal here, you can check to see if the left is different from the right by 1. If it's off by just like one of the bits is flipped, basically, then you can say, there's a smudge in this line, but then you have to pass that knowledge back up through the chain. So it's a little easier to brute force it and just say, I'm going to try every single possible subpattern and throw it at this lines of symmetry business and get back some answers, compare those to what we already had, et cetera, et cetera. We're making progress. Got 12 days left. Thank you so much for watching, and we'll see you in the next one.